Okay, all right. So looking at question 9, the cylinder question. So first of all, they're given, see how they're given the area of the surface area of the volume in the question. I'm sorry, but the formula for the surface area of a cylinder in the question, the volume is pi r squared h. The surface area is 2 pi r squared plus 2 pi r h, because the 2 pi r squared is like your two circles at the ends, and the 2 pi r h would be 2 pi r times h, because 2 pi r is like the circumference of the circle that goes around there. So they kind of match up. All right, so given that, we want to show that the area is equal to that. So you notice that this is all in terms of r. So your first step, we need a relationship between the r and the h, because we want to get rid of this h here. So we need to look for some other information. So all that I can see, I scan through and I find this number, 10 cubic meters. Even the units give that away. That is the volume. So the volume of the cylinder is 10 cubic meters. So that means pi times, now I better use the little r because that's what they've got in here, equals 10. So make h the subject. So that's 10 over pi r squared. And then you need to sub that into your surface area. So your surface area is 2 pi r squared plus 2 pi r h. All right, so we then need to just sub this in. So it's 2 pi r squared plus 2 pi r times 10 on pi r squared. All right, so now cancelling, pi's go out, r's go out. Okay, so we end up with the surface area is 2 pi r squared plus the 2's on top. 2 times 10 is 20, and it'll just be on this r here when we cancel it out. Okay, there you go. Okay, so 2 pi r squared plus 20 on r. Yes, bingo, we've done it. Okay, so that basically gives you the formula. So the second part of this, and I'll just give myself some paper, would be the calculus part of it. So you want to get a minimum value for the surface area, and we're going to find the R, so which it occurs. This is actually worth 3 marks. So you want to find the minimum value, show that A has a minimum value, finding R is the other part, and we don't have to find A. So we differentiate first. So let's write that 2 pi r squared plus 20 on r. So that's 2 pi r squared plus 20 to the minus 1 when you bring it up. A dash is 4 pi r minus, bring the minus 1 down, 20. Minus 1 is minus 2. So it's 4 pi r minus 20 r to the minus 2. A dash is 4 pi r minus 20 on r squared. So we need to make A dash equal 0. So you go 4 pi r minus 20 on r squared equals 0. Okay, if you bring the 20 over there, sometimes it's easier just to do the cross multiply method. You could also get a common denominator, which is 4 pi r cubed minus 20 on r squared equals 0. And then times by r squared. That's another way. Okay, so moving this up here, that's 4 pi r cubed equals 20. Divide by 4 pi. R cubed is 20 on 4 pi. R is the cube root of 20 on 4 pi. R equals the cube root of 5 on pi. Okay, so that's the R value. Now, I don't know if this is a minimum or not. So what I have to do is now check. So in order to do that, I could do 2 different things. But I'm going to go for A double dash because I'm thinking A dash isn't that bad. It's 4 pi r minus 20 r to the minus 2. So the 4 pi r part will just go to 4 pi because the r is just one thing, and you just get the number that is in front, which is 4 pi. The other part, the minus 2, it's 20 times minus 2r. Take 1 away, so that's minus 3. So it's 4 pi plus 40 r to the minus 3. 4 pi plus 40 on r to the 3. if r is root cube root of 5 on pi, when you put that in, I actually do not care what the value is. I just care that it is definitely positive. So a double dash is greater than 0, therefore it is a minimum when r is the cube root of 5 on pi. And I think that's all we have to do. We have to find r for which is a minimum and show it's a minimum. So your 3 marks there would be differentiating, solving, showing it is a minimum. Okay, here we go. Here's a sphere question. So see how this is popping up again? That's Pythagoras. So we've got to get the volume of a cone. So the volume of a cone is 1/3 the volume of a cylinder. Okay, and that formula has not been given in this question. So you do need to know it. Now A, that is the radius of the sphere. We've actually done this question earlier. It's just this one's in a HSC. There's a HSC one. So A is the radius of the sphere. So we know, oh, this is X.